Well, hello everyone, and welcome to the August 2022 edition of the St. Louis Java Users Group. So, for those who don't know, the St. Louis Java Users Group is an informal group. Attendance is free. There is no formal membership list. Normally, we meet on the second Thursday of every month except December, when there is no meeting. There's just too many things happening over the holidays for us to organize a meeting in December. When we meet in person, you can join us for food and social at 6 p.m. and the presentation starts at 6:30. And normally when we meet in person, our location is the Object Computing Incorporated Training Room at OCI, and that's at 12,140 Woodcrest Executive Drive, Suite 310. They're up on the third floor. I'd like to introduce the other members of the St. Louis Java Users Group Steering Committee. So from left to right, we have Ted Doyle, Todd Zimmerman, Bruce Alspaugh, that's me in the middle, Wei-Chi Gao, and Kathy Zwang. You can reach all of us on the steering committee if you send an email to that address at the bottom of the screen. That's javasigsc@ociweb.com. The St. Louis Java Users Group would not be possible without the support of our sponsors. So our inaugural sponsor, who's been with us since the founding of the group back in, I believe, 1997, has been Object Computing Incorporated. JFrog sponsors the Meetup subscription fees. It's free for you to use Meetup and RSVP and attend a meeting, but it does cost the Java Users Group a subscription fee to maintain a web page on the Meetup site, and they cover that cost. And they also cover the Zoom subscription, which makes it possible for us to have these remote meetings. So thanks a lot to JFrog. Signature Consultants and Adaptive Solutions Group are headhunters, and when we meet in person, they often will sponsor the food, but we haven't figured out a way to send that over the internet. At the end of the meeting, we will raffle 2 JetBrains licenses for any JetBrains product of your choice. But if you're watching the video after the fact, sorry, you're too late. You do have to be present at the end of the meeting to enter the raffle for the JetBrains licenses. Elastic sponsors gift cards, which we give away when we meet in person. Intertech is a training company. If you go to the Intertech website, if you're looking to learn some new skills, they have lots of online courses and so forth. They sponsor the famous Screaming Flying Monkeys. What are those? Well, they're just little dolls that if you throw them up against the wall, they scream. But they also have some coffee cups and mouse pads as well. Manning sponsors ebooks, and at the end of this meeting, we will be giving away 2 Manning ebooks. And so, again, you must be present to win those. And Pearson will also sponsor physical books as well. So thank you very much to all of our sponsors. We do have a few announcements. Yes, that's right. After a long hiatus, Java 1 is in fact coming back. I believe it's October 17th through 20th in Las Vegas, Nevada. And for all the details on that, you can go to that website there, right there, oracle.com/cloudworld/Java1. But closer to home and closer in time, there are 2 more conferences, and this one's in St. Louis. That's the Strange Loop Conference, September 22nd through the 24th in Union Station. So if you want the details on that, I believe it's an in-person conference. It will be thestrangeloop.com if you want the details on that. Now, JConf is a pretty big conference here. Registration is open, but that will be in Chicago, September 26th through the 28th. And if you want the details on that, you just go to 2022.jconf.com jOOQ.dev if you want all the details. And we do have a jOOQ member discount code. You'll see it there at the bottom of the page. And I'm also typing it in there into the chat window. So if you want a jOOQ member discount to attend that conference, there it is. It looks like a pretty good conference. I was looking at the speakers and everything that they have there. Okay. So as far as upcoming presentations go, on September 8th, we're going to try something here. I don't know if this is going to work. This is going to be purely functional programming for the JVM with Frege by Dirk Koenig or Koenig. I'm not sure exactly how to pronounce it. He is a professor at the University for Applied Sciences and Arts in Switzerland. Yeah, that's right. He said he's willing to do it at ridiculous hour of the night to be able to give a remote presentation. We're going to see if we can pull this one off. So he will be coming from Switzerland if we can pull this one off. On October 13th, we have another one, and that is Buried in Technical Debt. Here's how to make the right investments in your code. I saw this one at DevNexus, and it was a pretty good presentation, so I'm looking forward to that one on October 13th. So if you want to keep up with our presentation schedule, that's posted on the Meetup website. That's meetup.com/gatewayjug. And as we update the presentation calendar, all of that will be posted on our Meetup page. And as soon as you see something, you can go ahead and RSVP for it to get a reminder. So if you are interested in giving a presentation or sponsoring the jOOQ, you can email us on the steering committee at that same email address that I mentioned before. That's javasigsc@ociweb.com. So at this point, I believe we are ready for tonight's presentation, which is on jOOQ, Database Abstractions Without Distractions by Jason Lee of Red Hat. So I'm going to click Stop Share, and that should enable Jason to share his screen. So why don't you take it away, Jason?
All right. Can you hear me okay?
I can hear you fine.
Awesome.
And I
Hopefully
can see your desktop just fine.
All right. Those are two important things. I saw Brian Stansberry pop in there, and it's kind of a flashback. Brian and I work together, so I have to be real careful what I say now, I think, or he'll tell our respective boss. So awesome. So, but thank you guys for everyone for showing up. As Bree said, my name is Jason Lee. I do work at Red Hat. Let me, there we go, select the right window. So there's just some information about me. Sometimes people like to know a little bit about who's talking at them. So those are some of the highlights. I do work with Red Hat on the WildFly EAP team with Brian. A little time on Undertow project, networking and servlet stuff. I'm the president of the Oklahoma City Java Users Group. I wrote a book, Java 9 Programming Blueprints. It's probably a little bit dated, but if you want to go buy a copy, I'd appreciate the 20 cents I'll get off of that. But anyway, a lot of good stuff in there, I think. And I blog there at jasondl.ee. Nice little pun name. So right to it, jOOQ. What is it? That's a perfectly good question. I think it's Java object-oriented query, maybe. It was originally created as a library for complete abstraction of JDBC and all database interaction. If you've used JDBC directly, it's not really nice. I mean, it's not bad, I guess, but there are better libraries. It was built to kind of abstract that and as a way to make your code less database specific, a little more portable. It offers type-safe SQL building, dialect abstraction, so you can move from database to database fairly easily. In practice, moving from Oracle to SQL Server to what have you isn't necessarily a super easy lift and shift kind of thing, but this kind of helps a little bit. improved query execution, data retrieval, ActiveRecords, and just a lot more. I've been using Juke for a while, and it seems like every time I go to look at the docs or look at their Twitter stream, there's something new and cool coming out. So it's a great library. There's a lot to it. So just to look at some alternatives, so you can kind of get an idea of what space it's playing in. I mean, most of these are probably familiar to you: JDBC, Hibernator JPA, JDBC template or Spring Data if you're in the Spring world. MyBatis is a little older. JDBI, been around for a while. I've never used it, and there's probably a handful of others. But any sort of a library that you might use to kind of abstract away your database layer is kind of where Juke is working. But if any of those are working for you, then by all means use them. I'm a big fan of Juke, but I don't want you to think that my suggestion is you just rip out all your JPA code and use this. There are good use cases for each. So if what you've got is working, great. On new stuff, you want to try this out, I highly suggest it. However, I do like to show this. And again, past performance, no guarantee of future results. But this is a graph that one Juke user posted on Twitter. Links there, you can see on the source, but that's the load on the database. And where that green bar, which represents the CPU load, that's where it went from a Hibernate-based system to Juke, just kind of fell off a cliff. So there's a lot of stuff that Hibernate and JPA will do for you, and sometimes you don't need all of that, and it does, or it can lead to higher loads on the server and on your database as well. And you can kind of see where Juke fixed that a lot. So not making promises, but at least one user saw that performance. So what databases are supported? The short answer is all of them. Lucas Eater, I believe is how you pronounce that, has done a lot of work on a bunch of different databases, but specifically, here are some that you'll recognize and see yours in the list, then you're good. But it is important to note that Juke is open source, but there's also commercial license. So some features are only available to commercial license holders. So if you're using open source license like I am, here are your databases, and there are more. I just picked the ones that seem to be the most common. Should cover most of your open source database needs. If you're in a more enterprisey type environment, the commercial license does come in 3 tiers. I didn't break it down here because I'm not trying to sell you a license, but just know that if you're accessing any of these databases, that you will need to purchase a commercial license. I'm not sure, I've not tried, so I don't know, like if you tried to connect to, say, Oracle with open source license product, if it'll work, or if the bits just aren't there for it. I would imagine the bits aren't there because it's a separate download. But if you're targeting any of those databases, you will need to look into a commercial license, and Lucas will thank you for your support. So I've rambled, meta stuff. Let's get into the code as quick as we can here. So setting up the build, super simple. You've got a couple of dependencies there for Maven. Kind of hesitate to show it, but some people like to see see that kind of upfront. If you're using Gradle, you're on your own. I'm totally kidding. It's also super simple, just those 2 dependencies. It gets a little different later when we get into code generation, so that's kind of important to note, but there's nothing real special from a build perspective in the simple case. So your first step with Juke is getting the Dsl context. That's going to be your primary API. It's like the Hibernate session or the entity manager in JPA. All of your work will start with the Dsl context. Getting that instance is pretty simple. There we see an example of using either connection or a data source. And if you're writing the unit test, like the code I'll have samples of here is in a unit test. So we create a connection manually, or if you're in a application server or something else that can manage the connections for you, you can have it inject a data source, that kind of thing. So you can pool things, however you want to do it. Juke will work with that. If you need finer grained control, and I found haven't gone into details here necessarily, but sometimes when the SQL it's generated does kind of weird things, quoting and casing and weird things like that. It's got Juke does offer a settings object that you can set some properties on. You build a configuration object with that. And as you see down at the bottom, you just dsl.using, pass it your configuration, and there's your context. So either way will work. I tend to use the configuration object so I can kind of fine tune how things are going to work, turn on logging and different things like that in theory. So fetching data, that's what we want to do with this. So we'll look, there are two ways to use this. You can use just the type safe query generation, or there's a code generation approach to it as well that does a lot of the work for you. So we'll look at the easy one first. Just add the dependencies to your project and start writing your code. So we've got our DSL object. You'll see sometimes it's called DSL or context variable name, but that is the DSL context object. We're going to select the three fields, actor ID, last name, and first name from the table actor, and we're going to fetch them. You can see that the fetch is going to return a list. It's an internal object. It's a record of some sort with, depending on the size of your table, a lot of parameterized types. If you're really curious, you can assign that to local variable or inspect that, and your IDE will show you all the generic types on there. But what we want to do is take that and map each of those Juke record objects to our domain model. That's how I have it modeled here. It's an author record, and I've just got a static method on there to convert that from a record to my domain. And that looks like this. It's nothing real special. It's going to create an actor. I've got in the sample project, I'll share the link to, I've got kind of a builder pattern. So we just create the actor and call set ID on all those. And as we call record.getValue, we pass the field name and the type. So not bad, but there's still a lot of manual work going on there. You have to remember the field name, remember what the type is, and that sort of thing. So the better way, Juke done right, is using the code generation. And what that's going to do is inspect the database and generate some helper objects for us. That'll do a lot of that work. So it'll, depending on how you configure the code generation, it'll generate wrapper objects for your tables, for POJOs, stored procedures. It'll create DAOs, it'll create some POJOs for you, user-defined types, and just so much more out of the database. The neat thing is you can access tables and stored procedures very easily from your Java code. I don't show procedures or functions here, but if your database does use those, you can have access to that in a really nice type-safe manner from your Java code, or Kotlin, if you're so inclined. Generating code, I don't want to spend too much time on this, but you've got a couple options. Kind of lumped XML for command line and Maven into one because it's very similar, and then a Gradle option. So from a Maven perspective, if you want to generate code as part of your build, we add the Maven, the CodeGen Maven plugin, and we tie that to the generate sources phase, and we call the generate goal. Pretty straightforward if you're used to Maven. Configuration can look something like this. This is pretty simple, but you need to tell it what database to connect to, then some information about your database. And in this case, we're going to connect to a Postgres database. We're going to include everything from the public schema. We tell it where you want to put your targeted or your generated code, give it a package name. So there I put it in something that's very clearly generated, just so I know, or if I'm in a large project or open source project, people aren't going to go through and start tweaking the generated code because it'll go away next time it's generated. You can tell it where to put it. The project I have, I've got it dumping code out into the target directory, and I use the build helper to add that to my build. I have on my blog, I've got a more complete example using test containers and Juke and all that. I generate code and I put it into like source main Juke, and again use build helper. Then I commit that directly to that directory to my source repository, so I don't have to generate it every time. How you want to do that is up to you. It does take a little bit of time, not much, but if you have a complex schema, it might be worth committing it. But for now, I'm just sticking it in the target directory. So when I run generate sources, it's going to look something like this. I've kind of clipped a bunch out of there, but you can kind of see I'm using I think it's called the Sequila database, sort of a open source sample database that's out there with um, movie store type stuff in it. 31 tables, a couple enums, no user defined data types, no sequences, but it'll print out a whole bunch of stuff so you can kind of watch what happens. So if you want to do it from the command line, if you don't like it as part of your build, you can just stick that and say like jOOQ.xml, stick that little preamble there on the top of it, and the configuration XML looks just like it does from the Maven plugin configuration. And then this is why I don't run it from the command line, because you have to specify all these. The jar file kind of build your class path, and there, I think I copied and pasted that from example. You see it's using MySQL and not Postgres, but that's how you do it from the command line. Gradle is a little different. There's no direct support from the jOOQ group. They suggest using the Gradle plugin by some guy from Gradle. I'm not going to butcher his name. I did it DevNexus and I felt bad. But they've written a plugin for that, and jOOQ points you to that, so you can feel comfortable using that one as well. And it basically uses the programmatic approach here. If for some reason you want to generate your jOOQ classes from your Java code or Groovy or what have you, you can use a snippet of code that looks like that, the generation tool. All right, let's get on with it. So writing queries with CodeGen. So if you remember a few slides ago, and it was forever ago because I talk a lot, but we had this query, dsl.select, we list some fields, tell the table, tell it to fetch, to map. Not bad, but it could be a whole lot better. So what CodeGen gets us is something like that. One of the artifacts that it creates is, there's a class representing each table, and it's got some constants defined in there, and one of them, each table has its own constant. I don't show the imports here, but that's what you're telling it there. dsl.fetch actor, and it knows to, based on that constant, it's got all the metadata it needs for querying that table. So these are technically a little different queries. The first one selects 3 fields and then maps it. This is going to select every field, but or a lot of times dealing with entities, that's kind of what you're doing anyway. You can change that, and I'll show some examples here in a little bit. But if you want to select every field for every row in the actor table, that'll do it, and it'll map that to your model. So filtering data, the where clause is also pretty simple. dsl.select.from film, we tell the table. This time it's a little bit different because we're not fetch. If you want every record, you can say dsl.fetch, but here we want to build a query a little more manually. So we select, we're going to get every column since we didn't specify from film. Then the where clause here. Notice that this here film.title.like, for every column in the table, it's going to build a property on that class, and it's going to know everything about it you need to know, its type and things, so that as you're doing your queries and your data extraction, it already knows that title is from Java, it's a string, but in the database it's a varchar or whatever. You can call the like method on there. Notice that we still have to do the % on there, just like you would in SQL, but it should look very, very much like the SQL you're already writing, just sort of Java-ized, for good or bad on that. But there's I like, if you want a case insensitive like, there's a contains and things like that if you don't want to write the %. So a lot of helper methods on there. You can do film.title, hit the period in your ID, and let it suggest a bunch of some methods to you, and explore, go read the Java doc if you want. But this is going to select every film from the table film that has the word "the" in the title. Kind of a boring query, but pretty nice. And this is the SQL it's going to generate for those of you who like to see that. Pretty straightforward, basically what it looks like what I would write. But A more complex example, let's say we want to look at customers where the customer's first name is Mary and the last name is Snyder. So this is how we would write that. Dot where, some condition, dot and another condition, and then fetch. And when Juke generates the SQL, it's going to generate that. So that looks great. We've got the parentheses there around, so first name and last name have to match that. In this case, it's pretty simple, so it's a little overkill, but that'll be important on this slide. One more on the filtering here. Let's say we want to find all the customers named Marion Snyder or Terry Grissom. Kind of a goofy query because in theory, you're going to get at most 2 records, but there's a point to this. So if we write this query, which looks right based on indentation, because we're going to get this. And if you've written a lot of SQL, just I think at a glance, you can tell that doesn't quite look right. So we're going to find all the customers where Mary, the name is Marion Snyder or the last name is Terry. And for all those records, the last name is Grissom. Obviously, that's not going to work. You're going to get you 0 rows on that. And the problem is the parentheses. And this isn't necessarily like a Juke specific thing, obviously, but I pointed out because I've gotten burned by this many, many, many times. But you notice here in red, I've highlighted where those parentheses are. When you call .and or .or on something, it's going to attach it to the most recent condition. So in this case, we want to compare first name and last name. So we call .and on the first name condition, kind of lump that together. Then we call .or. So it's going to create the or on the condition that we just defined, that kind of a compound condition. So now when we look at the SQL generated, we have our parentheses here kind of show that we're going to select the correct rows. Again, we're going to get probably at most 2 rows on there. So kind of a dumb query, but it's I think helpful to see. You've got to be really careful how you group your conditions, and as your queries get more and more complex, you're probably going to run into that. And that's where dumping the SQL to a log is also helpful to kind of see what it's generating, because sometimes it's not real obvious. Joins, it's Juke supports pretty much anything you want to do in SQL, including all the joins. Cross join, Cartesian, if you're familiar with that. Sometimes you want to do that intentionally. Inner joins, outer joins, I'm familiar with those. I don't know, honestly, what a semi or anti-join is or are, but I list them because the docs list them. So if you know what they are and you want to use them, know that it's fully supported in Juke. I don't know what it is, so I can't really explain it, but I've told you it works. So there you go. The cross join, we're going to cross join store and staff. It doesn't allow you to do a where clause because it doesn't make any sense. It's just going to do a Cartesian join and return a bunch of information to you. Sometimes that's appropriate. An inner join, if you're familiar with that, I can't remember. I don't show the SQL on that, but if select from store on staff, can't remember what that syntax is. I grew up doing select from store comma staff where and then do your joins, but databases tend to prefer that inner join where you specify that join in the from clause, and this is what that's going to do for you. Outer joins, also the same: left join, right join, full join. And if you're familiar with those, get the nulls from this table, the nulls from this table, and nulls from both, depending on what you need. That's the syntax for that. Pretty straightforward. But this is where I think you start seeing the advantage of Juke is kind of from this point on. So far, we've been doing some explicit joins. You can see that in red. We want to join the store, table, address, and city. You can kind of see what those joins look like. And there's nothing wrong with that. It's explicit. It's clearly understood, but it's kind of repetitive, or it's a lot of tedious work sometimes. What Juke supports is kind of an implicit join. And as it analyzes the database, it's going to look at the relationships that you've defined on the database in between those tables to understand, hopefully, the relationship between those. So what that allows us to do is something like this. We know that each staff works at a store. Each store has an address. Each address has a city. This database is terribly normalized. So there's one St. Louis record, say, rather than each address having specifying string St. Louis. So very normalized. So that's what that looks like. But what this allows us to do is call the store method. That's a foreign key from staff to store. It's got say FK store ID. So it generates this method for us. So when we call staff.store, it's going to automatically modify the query it's building to add the join to make that connection on the foreign key and the primary key to make the join correctly. So we just say staff.store ID, and it does the rest for us. And you can see down here in our from, we just specify staff. This is super nice if you've got good, clean relationships between tables. It clears stuff up a lot. There's a little bit of a risk there that it kind of moves things up into your select. So sometimes it might not be quite as clear, but it's a great tool to have if you want to not have to specify so many joins, because jOOQ already knows what it is. So you kind of lean on it and let it do the work for you. Inserting. I haven't been watching if there's any hands raised. So Bruce, if there are any questions, want to interrupt, that's fine. But I'll just press on, sir. Inserting data supports that as well. Multiple ways: insert values, insert returning. If you want to get the primary key, it's got a set method, and we'll take a look at that. Default values: insert select, insert on duplicate key. I'm not entirely sure what that means, but if you use that, again, it supports it. But those first 5 there should be pretty clear. So inserting into values, there are a couple of ways you can do this depending on how you want to write your query. But dsl.insert into, the first property is the table, and then everything after that is a list of fields. So you don't have to insert something into every field if your database or if the table doesn't require it. So here we're going to specify each field we want to insert into. And notice we're specifying a customer ID. So say our application generates that a UUID or some other primary key generation, you can specify that and add all the fields. So you call .values, and you specify each of those values in the same order. Now this is nice and simple, but if you've got a complex insert, a large or wide table, trying to keep those parallel arrays, if you will, kind of in sync can be kind of difficult. But that does work for a simple case, and there's nothing wrong with it. Now, I will also point out the .execute here. I think IntelliJ has gotten smarter about this, and will give you a warning, but I'm thankful for unit tests, because my inserts wouldn't work, and I couldn't figure out what was going on. Just because I call insert into and specify that stuff, it's not going to do anything until I call execute. So you're likely going to forget that. So just file that away. If you don't call execute, nothing happens. Same thing on deletes and updates. Why is my data still there? Oh, I didn't call .execute. So remember that, and hopefully your ID will help you catch that. So insert returning. If you want to let the database generate the primary key, here's how you would get that. And I guess technically there are ways that some insert might generate multiple fields. I've not run across that, but you notice we've got a record 1. Excuse me. It's a record, has 1 parameter as type. It's an integer in this case. So we insert into. Notice we're not specifying the customer ID, just the store ID. We'll let the database generate it, and then we want to return the customer ID generated from the database, and then we call fetch1. It gets us our record. Then we call record.getCustomerID to get our key. So that's how you would do that. Now, if you remember here, we had to specify each field and then the values kind of separate, easy to lose track, especially if you go to add a field or remove one. So the insert set approach allows us to call insert into and then just a bunch of set statements. Set customer.storeID 1, last name dummy, or first name dummy, last name. So this allows us to specify them field by field and keep our field names and our values close together. So it's a little more verbose, but a little less error prone. And the nice thing about this as well is that the compiler is going to enforce type safety. So if I try to insert, a long there, say 5L or whatever, the compiler is going to complain this first name is a string, so I can't insert the wrong type there, which is super helpful. And then when you get into dates and things like that, it's going to help you catch that and make sure you're not putting in weird data. In this case, also, we're going to return the customer ID, just like we saw in the previous slide. So pretty straightforward there. Updating is about as simple as one might expect. We're going to update. We give it the table name, and we call the set method. I don't think this supports that list of columns like insert does. I've not seen that. I've not looked for it, but this seems like a much safer approach anyway. Update only the columns we're interested in, field name, value, type checking. Put a where clause on there because we only want to update certain fields. In this case, we'll update the first customer to tell it's not active. This database is a weird active bool and active field. One's a Boolean, one's an integer. So that's why that looks that way. And we call .execute. Again, if you don't call execute, nothing's going to happen. You'll just have a nice update object sitting there doing nothing. And the execute method will return the number of rows that are updated. Sometimes that's important. In this case, it should only be one. If you want to use a row value expression, we haven't dealt much with that yet. We'll see that later in a really cool jOOQ feature. But you can call .set and then just pass it a row. It's a little bit more like that first insert we saw, I guess, where you kind of list all of the columns you want to update and then list all the values. I'm not a real big fan of that, but different people write code differently. So if this is the way you like to do it, then there you go. Deleting data, super straightforward. Delete, give it a table name, give it a where clause, and call execute. Return the number of rows you've deleted. All right, aggregate functions. Database interactions aren't simply just selecting strings and inserting. Sometimes you got to do some weird math. So I just copied this list of functions that are supported. There might be some more from the jOOQ documentation. Again, I think I know what about 6 of those are. Start get down into rank and product and mode. I'm not sure what they are, but jOOQ has a Java API for those if you use those. But average, sum, count, max, median, min. Most people probably use those, and that supports that natively. So, and data definition language. Sometimes we may want to actually create our database schema in our Java code, for whatever reasons. And these are some of the functions, some of the Ddl operations that jOOQ will support. So you can write Java code, iterate over a JSON file or whatever to create tables, even create entire databases, domains. I think it's kind of a Postgres thing, indexes, sequences, custom types, functions, store procedures. All of these things you can do from your Java code. I don't show examples of that because I don't do it much, but if you find yourself the need for it, jOOQ does support that, so you can write that in a little more portable manner. Of course, you get into stored procedures and functions, and the function language is a little different on each database, so those aren't quite as portable, but there's a nice API for that. So a cruddy tour, that's a terrible attempt at a joke. So far, what I've shown is reading data from the database and then kind of copying that to a application-defined data model, which is fine. There's nothing wrong with it. That's like how you like to work, and I do. But you can instruct the code generator to create these CRUD objects. It's going to create an actor record, for example. So if you don't want to deal necessarily with insert into this table, setting fields, you can just create an object. You tell it to create new record of type actor. You get the actor record instance, and then you just start calling setters on it. First name, last name, I don't know, address, pick your pick. And then once you're done, you just call record.store, it will insert that in the database. It'll generate the primary key for you and return that in the record object, and you just pull it out and do what you want to with it. Return it as a REST URL, or whatever it may be. Similarly with updating, if you want to update a record, you can call fetch one. In this case, we want to get an actor of a specific ID. So it'll run the query, it'll get one record, return it to you, give you the actor record, set the fields you're interested in, and then you call actor.update, and it'll issue the update for you. It keeps track internally of what fields you've updated, so it's only going to modify the fields that you specify here. You may still run into issues, concurrency issues, if you behind a REST API and multiple people editing the same actor. So you may still need to do some work on that on the database side. But this does kind of minimize the amount of churn in the database, only updating what you actually modify in your Java code. And then deleting is the same. Fetch one looks just like above. You get the actor record object and call it .delete, and it does work for you. It doesn't handle transactions directly for you, so you might still need to do that. I think there's an API. I haven't shown that, but in the code I write, I've got the transactions managed by the framework for me using that connection that's shared with the context, so I don't have to worry too much about that. But that is something you'll need to consider. Some databases don't behave well for write operations outside of a transaction. All right, so I think we've got, what time is it? 7:17. Okay, I think we're doing okay on time. So advanced wizardry, this is, you want to talk about every time I look at the documentation, I find something new. And this is one of those. I've been using Juke for a long time, and just read a blog post about nested objects and multi-sets. Like, this sounds amazing. And this is one of those areas where JPA and Hibernate try to do something for you. You kind of get, I think it's the N+1 problem, whatever, where if you've got nested objects, it runs a query, you get to the main object, and then as soon as you access, assume you're doing lazy fetching, access that nested object, well, it's going to run another query. The proxy will get that data, process it, and then you can do what you want to with it. But that requires lots of trips to the database, which is why that CPU was so high on that. With nested objects and multi-sets, we can kind of get around that in a pretty neat way. So for example, using this database, we've got a one-to-one relationship. A customer has an address. That's all that the schema supports. So there you can kind of see the ERD for those that like graphs. I kind of stole that from the Sakila docs as well. The magic for that, we saw the function earlier called row. We're going to define what a row looks like. So what that looks like in the query is here. We define a row for the customer address, and we specify the fields we want. In this case, we're going to list address 1, 2, city ID. We'll just deal with the one. We're not going to go into the city table just yet. Postal code and phone. I will kind of call out here that weird little nugget there on the end. The reason that is there is because the column name is the same as the table name. So you can't have two objects with the same name. So Juke is going to tack on that underscore at the end of that. There may be some other clash mitigation logic it has in there, but it took me a while to figure out what was going on there. But if they're the same, it'll stick that on the end. So if you see that and wondering, that's what's going on. So that row is going to return those 5 columns, and then we want to map that to an object for our data model. So we're going to define a lambda that's going to take an address 2, those 5, and we're going to call this lambda that's going to create the object and return that for us. And then we can give that a name as address. So if we want to give it a user-friendly name for pulling things out later. Now what that looks like in use is this. So we weren't going down the city. If you really wanted to get the city information, you can nest that. So in our nested object for address, we're going to have a nested object for the city. And it's really the exact same thing. We're getting 3 fields, put a map it to a lambda, and return it as city. Rather than return the city row we saw, or city ID we saw here. Now we've got an actual object representing the city. So yeah, you're still going to need to make the joins on that. It won't do that for you. You can use the implicit joins. I think I'll show that here in a minute. But you are going to need to join the tables that are involved in that. So the SQL generator will find the tables right. Implicit joins. So this is what this looks like in a little more complete example. So we must select the customer, customer name, what other columns we want there, and here's our row for the address. Here's our row for the city, and when we get that back, we'll have, like if we just did these two here, we would have a string and an address object as things we would extract from the record. That's kind of verbose, kind of hard to read. Kind of like breaking down your functions or your methods. Sorry, doing a lot of Kotlin as well. Methods, you break those down into small, understandable chunks, give them meaningful names so they're easier to understand. We can do that here with function references and methods. So in this case, we've got a method called address row. We'll take a look at that in just a minute. That's going to do the address work for us. So we can select first name, last name, email, and address from customer with a customer ID equals 1, and we're going to map that using a function reference here, map customer. So rather than having that lambda right there in our code, we can just point to a function elsewhere in our class to kind of make our query a little smaller and easier to understand. So address row looks like this. It's basically the exact same code. It's just a method that's going to call the row method and return the value. You can kind of see we're returning a select field, and we'll call dsl.select. We're going to have a list of select fields in there that it'll generate the query from. And the type of that select field is address model, because we're returning that here with the map address method. And notice we are also nesting the call to city row. We extracted that out, and we can reuse that elsewhere if you need that. So the map address function method we saw earlier, I'm going to keep doing that, my apologies. We're string, city model, string. So we're dealing with the nested object in a more type safe manner, kind of aggregate that into a more meaningful model for us. So now we can call new address model, set city, and we'll pass it the city model object. All that's in one query. We don't then have to select the customer, then go select the address, then go select the city. It gets it all in one query. The way it does that, for those that are curious, is it, at least in Postgres, I haven't looked at how it handles it in other databases. It may be not quite as pretty, but in Postgres supports a JSON object. So in that field, when we select right here, it's going to select customer.first name, customer.last name, customer email, and it's going to have a function call in the generate SQL. I'll see if I can, I'll jump over the idea here in a minute and see if we can look at that. But it's going to create a query to get the stuff we want as defined in that address row method. And it's going to turn that as a JSON object. So when it comes back from the database, it's actually a giant JSON string. And then internally, Juke is going to take that JSON string and kind of break it down into, or kind of rehydrate or unmarshal that, if you will, into the record type that's requested. So we get it all in one query, which is kind of cool. The problem there, we'll see with multi-sets, is that JSON's not, I mean, it's kind of concise, but that can be a lot of data. So you have to be real careful. Do I want more trips to the database, or do I want to move a lot of stringified data across the wire? You'll just have to test that and see. So multi-sets kind of does the same thing, but for a one-to-many relationship. So it'll get the base record and 0 or more related records as a list, right? So this is where, like I said, it's going to build it as a JSON object and then do the work for you behind the scenes. So let's say if we want to select the store, get its address, and get all the staff that work at that store. That could be nobody, or it could be 100 people. But we don't want to query for every, if you've got 1,000 stores, if you have to query for each store to get that information, that's 1,000 extra queries. That's a lot of work on the database, and probably ought to change how you're querying it anyway. But this allows us to do a little less invasive. So we're going to define a multi-set, and in that multi-set, we're going to find another query. Here we want to select the staff from the staff table and get its address. You notice here, I call address row and I call staff.address. What I'm doing there is, see if I show that. Yep. I'm passing an address object into address row. What this allows me to do here is use this neat little function here to get the implicit join and then pass the address object to the row, so then I can get the city table. And we'll show that in just a minute. So I'm going to define a new query, staff. I'm going to tell it I want to select where the store ID for the staff member equals the store ID from the store, and that'll join us back to the parent table there. If you've done nested queries, it's the same mechanism there. So map staff, nothing real special here. I think it's just like what we saw earlier, but we're passing type safe information to our mapping. We don't have to deal with database types. So the address row, here's again where I pass in that address object. So I'm going to get the fields I want, and I'm going to call city row and then pass the address in. This will be important in just a minute. Define the row, we're going to map it to something. Okay, well, I don't show city row here, but what I do in there with that address object, I can call address.city and make that implicit join for me. So in my parent query, I don't have to worry about all of that. I've just got the implicit joins defined all the way down. You don't have to do that. I like to do that because it takes a little bit of work off. It does hide things. So again, depending on how you feel about that, make your own call there. But I found that super useful in what I've done. So I've got some more stuff there, but let me see if I can tab back over to idea here. Yeah. Hopefully y'all can see that just fine. What I'd like to do is just so you can kind of see code gen demo. Oh, yep. I've got this all written as unit test, so I'll have a link to the project. And I might start off writing as a REST API, and that's a little bit too much work just for a simple example. So most of these are just all unit tests, so it's all very self-contained. So here, like we're selecting from store, you can kind of see idea is, hopefully you can see that okay. There we go. Hopefully that's readable there on your screens for you. Basically what we just saw in the slides, address row, we're going to pass in store.address, multi-set, and then we're going to, I didn't point this out on the slides, but mapping a multi-set to a Java object is a little different from the nested object, the row. We call it convert from. It's going to pass R as some real strange type. Yeah, it's a result, kind of like a JDBC result set of type record 5. So basically what we've got is sort of like a list. So we want to take that list and we want to map each entry in that list to something else. So then we're calling list.map. And then to map each entity in that list, then we pass a mapping function. It's a little weird, but that's what this looks like for mapping the multi-set. A little confusing at first, but super helpful. But you can kind of see how IDEA is filling in the types there, so you can get a sense of what those weird things look like. But let's, just for grins, see if I can get the right keystroke here. We're going to extract that query into an object here. So we can see select join step. It's an internal type you typically don't have to worry about unless you do something weird like this. We've got it's a record with 3 fields. We've got a store ID, the integer. We've got an address model and a list of staff model. You can see how the compiler can look at this and understand what's coming out of these functions are these specific types. Since we're mapping this to staff, we're getting a list of staff models. We are mapping the address row here to an address model. Sorry, this is getting that here, the address row, we're mapping to an address model. So that gets us that type, and then the store ID. All that stuff comes from the code generator. So if I go through, and which I've had to do, change a date type or something, and I regenerate my code, my Java code that uses that now no longer compiles because the type changes. So super nice, and make sure you're passing good stuff in. And if the database changes, then your code is forced to change. You don't find out at runtime when things blow up. But notice too here how I call address row a couple different times, and I'm passing a different address object to it. So this allows me to join from staff to the address table and from store to the address table, and it generates that implicit join for me. So hopefully, if all goes well, I should be able to. I'm a little nervous about doing this because this is where things really go off the rails. But I'm going to try to debug that so you can kind of see what the SQL looks like. Okay, so here we built the query, we saved it as the query object. It's kind of hard to see there. So let's view that as text. So the query this is the SQL that generated. Notice the row method here, select, coalesce, JSON aggregate, JSON build array, and I've never used those directly, but this is all generated for us. So what that's going to return is a, I don't think I can't run that directly, but that's going to return a JSON string basically based on all of these fields, and then Juke will, like I said, will kind of reconstitute that for us. But this is all done for us. So we're going to get the store and every staff, every address, every city for all of those in a single query, which is super awesome. It's one trip, but like I said, it is a lot of data. So you've got to be careful that you're not writing massive queries. And in that case, you probably want to rethink how you're getting your data, and that'll depend on what your application looks like. But for smaller data sets, if you're or expensive connections, if you've got a distant database or what have you, this is a way you can get all the data in a single trip, and hopefully all the other parameters will be fine. But like I said, you can, all of these objects, all these function method calls that we've got, you can extract that into a local variable if you want to kind of inspect what's going on. And down here in the query, which is kind of hard to see, won't let me zoom in there, but you can inspect that object and get a sense of what's going on and play with it if you're curious. I like to dig into the depths of things like that. But that did, like I said, it created the joins for us from store join address, assigns an alias that's unique, join city, alias that on. Of course, this makes it hard to read the SQL because then, what does that weird alias refer to? But it prevents any collisions. If you're joining the table multiple times, it aliases it correctly for you. And then you can run that. I can copy and paste that into a database connection if I want to and see what it looks like. I just don't have that connection set up at the moment. I don't believe, I'll double check. dbeaver, if you don't use that, I highly recommend. It's free and very, very nice and functional. Install from the Snap Store. Oh, sweet, it is working. So there's all the tables in that database. So let's live on the wild side. Let's copy that value. Let's come over here. All right, paste our query and run it. And I hope you can see that okay. Yeah, that's copy. This is the row for the address. This is the list for the staff right here. So if we come over here, Json Formatter. So this is a single field that the query returns, and this is what it looks like, the JSON that is produced from that. It's kind of weird formatting from the formatter, but you get a JSON object like that, and Juke will do the rest for you. This is what the row looks like. Oh, that is not JSON. Excuse me. That's yep. So anyway, that's what the query looks like on the wire, and the data it gets back for those that are super curious about what that might look like. And then we can step over that. It runs the query. It's going to fetch in the store model. And now our stores object has 2 records with an integer and address model and a list of staff objects. So, super cool. It's one of my favorite features. I'm trying not to abuse that. So, but moving on. Like I said, there's a lot to the library. There's always something new I'm learning. Conditional conditions. I've done some stuff. Like, so you've got a REST endpoint, and you can pass in a query parameter to filter the data, whatever that might be. But the value might be null if the request doesn't provide it. So in your code, when you pass that down into your database layer, whatever that might look like, you've got this field that may or may not be null, but you don't really know. So what I had done previously was I would build the query to a certain point, save that in a local variable, and then say if field not equals null, then query equals query dot and whatever the condition might be. What conditional conditions will allow you to do is you can use like a little ternary operator, field equals null, or field not equals null, question mark, what your condition is, or colon, then DSL dot no condition. So if that field is null, it's going to create a no condition. So basically, it's not going to render or produce anything from your SQL. So you can do all that in line without having to break the flow of your code. So super helpful. Kind of helps make that a little cleaner and neater. You're not dealing with weird Juke types in your code directly. So lazy fetching with strings. I've not gotten into that, but if you have a large data set, rather than processing everything all at once, you can just get it lazily as you need it, or you can work with it in a string fashion. Reactive fetching, reactive is kind of all the rage these days. So if you'd rather react to each row as the database returns it rather than waiting for everything to be read and then you loop through it, you can do that as well. Batch operations, if you're reading from like they're importing from or to an XML or CSV or whatever, if you're reading data from some sort of external data source, network, file, whatever, you can build up a batch object and do, say, multiple inserts or multiple updates in a batch manner rather than insert, because that's expensive. Multiple trips to the database, roll them up into a group of 100 or 1,000 operations, whatever. Execute the batch and keep building. So that helps you lower the load on your database, which is pretty nice. Stored procedures and functions. It wraps has APIs for calling those and passing data to it, get data from. I've not done anything with that, so I can't really demo that for you. But if your database is heavy on procedures and functions, you've got first-class support for that. And if you download the slides or whatever, all of these are links. You kind of link to the documentation showing you what's going on there. So for resources, jOOQ.org is the best place to go. It's got pretty good documentation. Sometimes things are a little weird, I'll be honest. Documentation being what it is, it works great for some people, and sometimes it doesn't answer the questions I need. So in that case, I go to Stack Overflow. It's a good place. You've got a number of questions there. Look at that tag. You can ask on Twitter, and I've done that sometimes. I try not to ask questions on Twitter a whole lot because there are better forums for that. But sometimes I find myself just kind of grousing on Twitter, which is something I shouldn't do. But Lucas is great about being on Twitter, and he's actually asked me sometimes to go to Stack Overflow and ask it there, so that the question and answer are recorded for for posterity. So, but if you just have a quick one-off, you can post on Twitter as well. Just tag the jOOQ account, and Lucas will be along shortly to help you out. So that's really all I've got. Happy to answer some questions if I can. Here's some information about me, my Twitter handle, my blog, LinkedIn. The presentation source there is on GitHub, and I think Bruce will email out a link. So I will go and stop sharing here and let Bruce take it over.
Okay, well, thank you, Jason. It appears that we do have a few questions in the chat. If you'd like to take a look at some of those. I think the first one, they were just asking if there's a link to the code repo so they can see that, but it looks like you've got something there on your last slide.
Yes, if you go to that presentation source, I'll click the link now and see what happens. Yep, okay. That's the GitHub Pages version of that. But if you go to the master branch here, the slides are in the slides directory, and the code gen demo is where all the stuff I was showing in IntelliJ is going to live.
Would you mind posting that URL in the chat? That way people can copy and paste it and bookmark it and be able to access it.
Yes. I got fancy and did a GitHub page for that, so it kind of makes things a little weird if you go right to GitHub.
Great.
So,
but it is, for the people on the recording, it is on that last slide, and people can just run the recording back and just freeze frame if they ever want to look at it again. I think we had a few more. What do you see as the advantages over Spring Dated Jpa?
Well, yeah, I don't know. I like jOOQ over just JPA in general because JPA does a lot of magic for me, and sometimes I catch myself getting burned by that. I've not used Spring Data JPA enough necessarily directly to give you a specific answer on that. But I've written JPQL or HQL over the years, and sometimes there's a weird mismatch between what I'm writing in the query and what I want the query to actually do. So I find jOOQ's approach to much closer to SQL and easier, I can more reliably express the query I'm wanting to do. Now I do know, like with the Spring repository, you've got that funky magic where you just sort of write in English what you wanted to do in the function name, the method name, and Spring just does the right thing, and that's pretty awesome. So I mean, if that works for you, that's great. And the jOOQ docs actually has a big section on jOOQ versus JPA, and kind of listing why you'd want to and why you wouldn't want to. If you're doing anything with large object graphs, and maybe JPA is a better choice for you because it'll handle that a little more natively. And then any of those performance or load issues, you'll just have to find a different way to mitigate, and maybe it's not an issue for your particular application. But if you're using Spring Data JPA and you're happy with it, then like I said, go ahead and use it. There's nothing necessarily wrong with that. Each tool is better than another in specific scenarios, or can be. So that's probably not a real good answer to your question, but it's the best one I can give you.
Okay. One of the things that I like about the jOOQ approach is that it strikes me as being a domain-specific language. In effect, you're writing SQL sort of in Java, but it's like Java-ized SQL. But what you're leveraging is the ability of the compiler to compile time check that, as opposed to just putting in some SQL string buried, no telling where. Could be in an XML file or some external file or something like that. I don't know.
Yeah. And I've run into that with JPAQL as well, that if you have a typo in your query, especially if it's real complex, you're not going to know until you hit runtime or your unit test if you're doing things right.
Right.
But with jOOQ, pretty much right at compile time, if you've messed something up, it should complain and force you to fix it there.
Yeah, and I haven't used Spring Dated Jpa much, but I've used Hibernate, and sometimes it's just kind of hard to know what the SQL is going to look like.
Yep.
That can come out of this thing. Whereas if you're using a DSL like that, you have a pretty good idea what the SQL is going to look like based on what you're flat out writing there, I suppose.
Yep.
Of course, there's a
Yep.
million ways to optimize it too. And
yeah, and I will say JPA and Hibernate do offer things that Juke does not. You know, it's got a certain level of caching and things like that Juke makes no attempt, and I don't think has any intent to provide. So if you need caching or anything like that, you know, you might look at caffeine or something like that, kind of build it in yourself. And I think it's JPA has better native or built-in transaction support and that kind of thing, or it leverages JTA or something. But so I mean, there are some things that Hibernate and JPA bring to the table that Juke just doesn't offer. So again, just like any library, you just have to kind of look at what you're wanting out of it, what your application needs, and decide if it's the right tool. It may not be, and Lucas is fine with that. He makes many outfits, so, and if you use it or not makes no difference to me. So
okay,
you know, just find whatever works best for you and run with it.
right. I think Maximilian had a question. I'm trying to read that in the chat. Maybe you can see it too here, Jason, about a table generator record or POJO.
Right. I've not used the store procedure support. As a general rule, I don't like store procedures. I don't know, they're not as portable. I know, like I did work in a shop where we were heavily invested in store procedures, and they make sense. But for stuff I work on, I tend to stay away from that. So in the context of Juke, I've just not had to use that with the store procedure. So I can't say. I will say though that like as I noted that last slide where it mentions store procedures, that is an actual link. It'll take you to the Juke docs that discuss that, and you can get all kinds of great examples of what that might look like.
Yeah, I suppose different shops have different philosophies about how much business logic do you actually want to put in the database? Where does it really go?
Yep.
Yeah, right. Okay. Let's see. I think I see another message just popped up. Oh, that was just thanks for the answer. I had a question about it. You mentioned in passing about transactions, but you didn't use it very much. How do you usually handle it? Because I was thinking maybe a way, potentially, I haven't tried it, would be if you might use like a try catch block. And if you like put some data manipulation statements in the try block, and at the end of it, you commit. And then if an exception gets thrown, like maybe you're doing a bank and you have to deduct from one account and deposit the same amount of money into the other account, you don't want to deduct from one and not do the deposit. You want the
Right.
whole thing to commit or none of it.
Yeah.
And then maybe when you catch it, then you would just roll back the transaction back to that begin. I don't know.
Yeah.
Maybe
I mean,
Juke
that
has
is a
something like that.
I don't think it has anything really specific about transactions, like in terms of APIs. I think you're going to still deal with was it connection start? It's been a long time since I've dealt with at that level.
Okay.
In
Or
the
maybe
project
you
I'm using
just
on,
do raw JDBC code. Can you intermix
sure.
some just
Yep.
raw JDBC in with your Juke?
Mm-hmm.
And it's
You
not,
can do
and
that.
it's okay, and it's not gonna step on each other's toes or anything like that. You mean there may be something cached or no telling.
Yeah. If you're using the same connection, then there's no reason you can't use, you know, JDBC APIs to start the transaction, use Juke for your query, and then back to JDBC for the commit. If you're in a JTA environment, you know, I can annotate methods with at transaction, and I get a transaction created automatically for me. It's rolled back automatically if there's an error. And that works great for my use case. But if you need something more fine-grained, where you need to undo work you've done somewhere else, perhaps, then try catch block, try catch finally, I guess. Also works just as well. Just kind of depends on what you need.
Okay. Does anyone else have any questions here? I'm just looking in the chat, or I think Ted is watching. You can kind of wave or say something if you'd like to ask to unmute if you have any questions here for Jason. Okay, well, I'm not seeing anything, but it looks like everybody, oh, here we go. Does Juke support annotations like JPA?
What type are you, like the entity and the relationship annotations, that kind of thing? If that's what you mean, well, let me back up. I think
Oh, he's
generally,
saying, for example,
okay.
at join or at one-to-one.
No, not that I'm aware of. JPA, you're defining your model a lot of times kind of manually. You're writing your entity and defining the relationships and the structure of your data. Generally manually, in my experience, it's been handwritten code. Juke kind of comes the other way by looking at your database and generating all those objects for you. So you don't need to express explicitly a one-to-one or one-to-many relationship or anything like that. Juke just knows from looking at the database what those relationships are and generates the code appropriately. So you don't have to define it in code and in your database, and then JPA kind of puts two together. You just define it once in your database, and Juke will interrogate that and build what it needs to do the right thing. That answer your question?
So it sounds like what you're saying is it doesn't need to do those annotations because what Juke does is it's going to read the database and generate the code to match your database schema, whether it's one-to-one or how the joins work, rather than you writing code and then you have to tell the code, well, this is the way it is in the database.
Right. Yep. And I've not gotten this to work personally, but it can also read, if you have a file that has all of your DDL statements, like I use Flyway in the project I'm working on, side project, but I use Flyway to create the database. So in my build, I actually use test containers, start up a Postgres instance, I run Flyway against it, it creates the database, then I run the Juke code generator, it looks at Postgres, generates the code, and then after the tests are done, the container is shut down. But that takes some time to start the container, especially if you're downloading all that. I can point the Juke code generation to that Flyway migration file that has just all the DDL statements in it. And in theory, it's supposed to be able to read that SQL and generate code based on that. So you don't actually need a live database to generate your code. Like I said, I'm not had any personal luck with that, but he advertises that as being functionality supported. So I'll trust him on that. I just haven't dug into it much.
Yeah, that sounds like Juke here is pretty powerful as far as what it can do, and it looks to me like a pretty nice tool. And this Flyway, I think I've hit it before. I think I'd like to see maybe at some point we might be able to bring you back and you can tell us a little bit about Flyway at some point.
Yeah, I'd love to.
Great. So are there any other questions out there in chat? If anybody doesn't have any more, then I guess probably I'll just stop the recording and then we'll probably end up going and doing the raffle. So all right. So at this point, people can't hear us, but I'll clap for everybody else, which is the way we would normally do it if we were meeting in person. Oh, I heard a little more clapping here. Yeah, now we're seeing in the chat here. Thank you. A nice presentation. All right. So I think I'll start the recording here at this point.